Hi everybody, I'm going to go through calculation all sorts question 8. First thing I've done is RTFQ. I've read the full question all the way through, and then I've made myself a flow chart like we've done in lessons, just breaking that question down. So 10 grams of copper and magnesium powder was mixed. It was mixed with hydrochloric acid, and the magnesium reacts with the hydrochloric acid, but the copper doesn't react, and they've given us a ratio. It's then filtered. The purpose of that to get rid of the copper that hasn't reacted. And what we'll have is the magnesium chloride product solution that goes through the filter, but also we have unreacted HCl. That's the thing to realise. The resulting solution is made up to 250 centimetres cubed with water, and then they take out a portion of that and they react it with some sodium hydroxide. The question is asking us to find the percentage by mass of magnesium in the mixture, so it's mass of magnesium that we're aiming to find out from this. Now, this is a true back titration, okay? We're reacting something with one chemical and then using another chemical to react with the original chemical to find out how much had been used. And that's normally the purpose of these back titrations. This is where the flowchart really helps. Work backwards through your calculation, and I've coloured these just to make it a bit easier to follow. So I'm going to go with the red section first, because as I said, it's a back titration, we're going to go backwards. So what information do we have? We have 36.8 centimetres cubed, which is a volume, okay, and we have 0.2 molar, which is a concentration, okay. Apologies for my writing with this pen. Now, if we've got volume and concentration, we can therefore work out moles, okay, remembering our equations. So that's what I'm going to do first. Moles of NaOH is concentration times volume, 0.2 molar times 36.8 divided by 1000. Remember, we have to convert centimetres cubed to decimetres cubed. So, first thing, I'm going to be tapping on the calculator as we go. 7.36 times 10 to the minus 3 moles. Now, that is the amount of sodium hydroxide that's reacting with the HCl that's left over in that small portion. Now, this is one of the ratios that you need to know, that sodium hydroxide and hydrochloric acid react in a 1-to-1 ratio, and that's every time. Therefore, the moles of HCl in the 25 centimetres cubed is going to be 7.36 times 10 to the minus 3 moles as well. And that is the red box. That's all the information we can get from that, nothing else we can do. And we move on to the green. Well, the green is telling us that the solution was originally 250 centimetres cubed. 250 centimetres cubed divided by 25 centimetres cubed is a factor of times by 10. So the moles of HCl in the 255 centimetres cubed is going to be 7.36 times 10 to the minus 3 times by 10, which is 7.36 times 10 to the minus 2 moles. And that's how much acid was left over in the solution after the reaction with the magnesium. So what can we then do? We've done the green box, I'm going to move on to the blue. Okay, the blue box is telling us that magnesium reacted with a certain amount of acid. Now we've got a volume and a concentration of acid, so we can work out another lot of moles. But this is the original moles. This is how much hydrochloric acid we started with. Again, conc times vol. This time it's 1 molar times 100 over 1000, so 100 centimetres cubed divided by 1000 to get to decimetres. And so what we end up with is 0.1 moles. So we've now got the original moles of acid, and then we've got the moles of acid that was left over. What can we calculate with that? Well, we can work out the moles of acid that reacted. That is going to be the original, which we had in blue, and that is going to be minus the green value that we worked out, which was the excess, the sort of leftover acid. I'm going to switch to black. And so we have 0.1 minus 7.36 times 10 to the minus 2 . Sorry about that, all fingers and thumbs on my calculator. And that comes out to be 0.0264. That's how much HCl reacted with the magnesium. Okay. Now, if that's how much reacted with magnesium, we have got a ratio. We've got a ratio just here at the top, which is Mg to HCl. And that is a 1:2 ratio. Now, we've just worked out that it's 0.0264 moles of HCl. So if we divide that by 2, that will give us the moles of magnesium that was in the original mixture. Well, what are we trying to find out? If we look back up, we're trying to find out the mass of magnesium so we can work out the percentage by mass. So that's the next step. Mass of Mg equals moles times Mr. We've just worked out the moles, and the Mr is 24. Might be a decimal place there, but I'm not too fussed. 0.3168, and therefore the percent by mass is going to be 0.3168 divided by 10 times 100, 3.17%. Let me know if you're still stuck.